topic. What is momentum? Suppose you're standing at the bottom of a hill and you're faced with the option of stopping a runaway semi-truck or stopping a runaway bicycle. You'd probably choose to stop the bike, right? The reasoning behind this is that the semi-truck has more momentum than the bike. Momentum simply means mass in motion. The semi-truck has a large momentum because it is very massive, but it also has a large speed, which influences momentum as well. The bicycle also has momentum because it has a large speed, but because its mass is less than that of the truck, its momentum is also less. This relationship can be described in an equation. Momentum equals mass times velocity. You may remember that velocity is speed with direction. So if an object has a large speed, it also has a large velocity. Our momentum equation can be simplified even more by substituting the words for symbols. P equals mv, where P is momentum, m is mass, in kilograms, and v is velocity, in meter per second. As you can see, if you increase one of the variables on the right side of the equation, either the mass or the velocity, the momentum on the left side must also go up, in order to keep both sides equal. If you increase both mass and velocity, the momentum goes up even more. In this way, we can see that both the bicycle and the truck can have a large momentum, but the truck is still more, because it is far more massive than the bicycle. This also means that an object at rest does not have momentum. The velocity of an object at rest is 0. So there's no movement. In order for an object to have momentum, it must be moving. Hope you understand, friends. Now discuss more interesting about momentum. An important thing to note about momentum is that it is a vector quantity. This means that it has both magnitude and direction. Velocity is also a vector quantity, because it has both of these components. Unfortunately for us, the direction of the momentum is the same as the direction of the velocity vector. But in order to fully describe the momentum of an object, you must include its direction, otherwise, it's not a vector. Now look at some examples of momentum for better understanding. As you know, an object of any size can have a large momentum, because it depends on the speed of the object, as well as its mass. If its speed is more, then its momentum is more. If its mass is large, then its momentum is large. Now you think that all objects which have greater mass have greater momentum, but it's not true for all cases. Let us discuss in this case. A supertanker ship that is coming into port may not be traveling very fast through the water, but it is quite massive. So it needs to begin slowing down long before it gets to port in order to be able to dock safely. Now discuss how the momentum of two vehicles same. Let's say that our bicycle speeding down the hill is 1/2 of the truck mass but is traveling twice as fast. In this situation, each vehicle has the same momentum. That may sound a bit far-fetched. So let's look at it in the equation. For the truck, the momentum is P equals 2mv. The bicycle momentum is P equals m2v. Can you see how this would equal the same momentum for both vehicles? As long as you know the mass and velocity of the object, you can determine its momentum. A 5 kg ball rolling at 10 meters per second to the right has a momentum of 5 kg 10 meters per second, or 50 kg by meter per second to the right. If that same ball increases its speed to 20 meters per second, we simply double the momentum since the velocity component is doubled. The new momentum for this ball is 100 kg by meter per second, because the momentum increases or decreases by the same amount as either the mass or velocity. We say that they are proportional. All this means is that as one variable changes, the variable on the other side of the equation changes by the same amount. Knowing that they are proportional helps us understand why the bicycle and the truck can both have the same momentum under the right conditions. Now discuss more daily life examples of momentum in a short way. A semi-truck full of logs has a large mass and must slow down long before a stoplight, because even with a small velocity, it has a large momentum and is difficult to stop. A bullet, although small in mass, has a large momentum because of an extremely large velocity. A karate expert can generate enough speed with his fist that the momentum can carry through several bricks, breaking them. Hope you understand, guys. Thank you so much, guys, for watching this video. Hope you like it. Share it with you friends. Bye, guys.